welcome to the channel. Today we will be talking about chemistry. So, chemistry, we are talking about particles. Okay, let's start from the basic. So, have you ever noticed or went around each other or just, partially noticed of the things that are made of? Of course, from our previous classes, we have learned about this particle. Now, what exactly are particles? Are we aware of it? Particles are the smallest things that make up a large thing. Okay? Suppose for a glass, let's say, a glass is made of many glass particles to create this glass. The water inside it. There are also many water particles to keep up with the shape and size of the glass and the volume of the water in the end. So, how long can a particle be broken down? Well, there is one answer that is called atom. What are atoms, you may explain? Or ask, and I will explain. Atoms are the smallest particle which can only be broken down into electrons, protons, and neutrons. So, what exactly are they? They are also particles. They are the tiniest particles which cannot be broken down furthermore. Now, let's start with what exactly particles can do in our daily life. So, first, let's ask ourselves this thing. For example, in the lab, we have water in a beaker. Let's say these are water particles. For that, we put in a purple crystal called potassium permanganate. See, these are called potassium permanganate, and this is a crystal of it. So there are many particles in the crystals of potassium permanganate. Now, what exactly will happen if we put crystal of potassium permanganate in a beaker of water? If you don't know, potassium permanganate is the color purple. I'm using a blue pen to distinguish between water and the crystal particles. You see, there is something because this is right after you put it. I'm going to draw another to make you understand. This is the water exactly after a few minutes of using the potassium permanganate. 5 minutes, let's say. And then within 40 to an hour, we can see that the entire water has turned purple. Now, why exactly does that happen? Have we ever asked ourselves that how does this exactly happen? How does something crystal can dissolve in water and move between them? The answer is easy. The entire thing is called diffusion. Now, what are exactly diffusion? Diffusions are when the particles of a lower concentration is exposed to the particles of higher concentration until it reaches an equilibrium. Now you might be asking, what is an equilibrium? Well, the state of equality on both of the sides of the concentration is called equilibrium. You may note down whatever I'm speaking about. Let's take a fresher page. Now, the tiny particles that I have talked about, neutrons, electrons, and protons. Okay? So what exactly are they, and why are they so significant in chemistry? They are not only significant in chemistry, they are also very, very significant for physics, biology, and practically everything. And it plays a huge role for chemistry next time. Protons have positive charge. Neutrons have no charge. And electrons have negative charge. So, what exactly will this say? Well, this will say a lot about the atoms and why they are required to learn to be learned about. Protons and neutrons cluster. Let me use different colors. So let's say protons are of this color, neutrons are of red, and electrons are purple. Let me explain to you why I'm distinguishing the colors. So as we can see, the first dot that I have given as is the proton. Then I'll be dotting a red, again a blue, again a green, red, green, red, green, red, green, red, green, red, green, and red. So as you guys can see, they are all clustering in the form, and they're building a nucleus. So this is the nucleus of an atom. Electrons have a very fun business. So what electrons do is that they orbit right around the nucleus. Now that also depends on how many electrons are there in each element, which I'll be coming in later. So let's say potassium. Potassium has 19. So let's start counting. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So it makes 8. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I need another electronic shell. Excuse me for my bad drawing. This is this. Now it has 19 electrons of potassium, and this is how we are doing it. So it is needed to have a perfect sense of how each element will react with other elements. Because if potassium has 19 electrons, calcium will be having 20. Then again, magnesium will be having 12, sodium will be having 11, boron will be having 5, and beryllium will be having 4. So, as we know and as we're seeing, it is not the same at all. So, we're going to try and see what else we are missing on. Interesting topic which we have been learning for a long time. Solids, liquids, and gas. So we are all familiar with these three terms at least. Now, let's see how indifferent it will be. Well, solids are solids, liquids are liquids, and gas are gas. But let's take the example of water, which is a very relevant example because it exists in both solids, liquids, and gas. And everything is known to us. So let's say when water is in the solid state, it's ice. When it's in liquid state, it's of course water. When it's in a gaseous state, what it is? Vapor. Now, have you seen how each individual of these occurs in a certain temperature? So, for example, like below 0 degrees, you get the solid, which is ice. From 0 degrees to 100 degrees, it is liquid, and above 100 degrees, it is a vapor. Now, how does it happen? And why do they all have an exact temperature? Mind you, if it is solid, if it is pure water, they will have sharp temperatures for each of their states. Now, when you change a solid to a liquid, we call it a solidification. When it goes from liquid to gas, it is called an evaporation. Now, the same thing happens when we put it in the reverse order. Say, for example, gas to liquid. I have made a very big mistake. I will be explaining why this is not solidification. So, gas to liquid, it is condensation, and liquid to gas is solidification. This is called the melting. Now, why is this called? Oh, I have made another mistake. It will be liquid to solid. So when it goes from liquid to solid, it is solidification. When it goes to solid to liquid, it is called melting. So do not mix these terms up. Alright? So the melting point of water is 0 degrees. The boiling point of water is 100 degrees. Now, the same goes when we go in again, the reverse method, the reverse happens at 0 degrees, and then again solidification, or you can say below 100 degrees. Solidification is above 0 degrees. Now, mind you, these degrees are all in Celsius. I have not mentioned that, but they are all in Celsius. We are not using Kelvin or Fahrenheit at the moment. But in order for that, there is also a graph which we call as, what do we call it? Think about it for a while. Yes, we call it the heating curve. Now you will see this thing. Okay, so we have set 0 degrees, 100 degrees. So before 0 degrees, it was minus 4 degrees Celsius. Let's say that it is in solid state, it is in liquid state. So the particles keep running, 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 and running from each other till they reach 100 degrees Celsius. Why do they need to reach 100 degrees Celsius? Because at 100 degrees Celsius, all the particles have enough kinetic energy for themselves to move away from each other, enough to turn into gas. Been here for a while, and then they all turn into gas. This is the liquid state. This is the gaseous state. I've seen here. This is known as the cooling heating curve. Now, of course, there is also heating curve, a cooling curve, which goes kind of like same, but in the reverse order. So we're going from here to here. This is the gas. This is the 100 degrees. Then it goes all the way to 0. And from 0, it again becomes solid. This is called the cooling curve. So this is the graph that we can do. It is also very easy to understand, right? Like there's a constant point where it has to be melted down, it has to be solidified to make it solid. And again, there's a lot of time that you have to waste to take the particles so far apart that they become gas. So the properties of solid, liquid, and gas are known to us. Why? Because solids have a very compact, let's say, presentation of particles. Particles that don't have space. Liquid can hold spaces of where they're kept, but on the other hand, they have a little space, a little more space than solid for movement. Gas, on the other hand, they're moving randomly, rapidly, recklessly. You cannot stop them. You can never stop them. They're completely unstoppable. That is how gases are. They are so far apart from each other. Like if this is one particle in the gas, this is another one. And this is due to how much pressure they exert on each other to stay apart. They do not need each other to be independent. Now, that is all for today's class. I hope you liked it. If you did, Please make sure to rewatch it every time you get stuck or did not get any other explanation. And yes, I hope you guys have a good day. See you on another video.